Hi, welcome back. I'm Professor Ridge, and for today's lesson, we're going to be covering 1.6, Properties of Exponents. All right, so I like to let's start out with definition of the exponents, again, just in case. So x to the n is equal to x, it's repeated multiplying x times x times x, dot, dot, dot. And you're going to have n factors of x. So if I had x to the fifth, that equals x times x times x times x times x. 5 factors of x. All right. So with that in mind, we're going to go through all the properties of exponents. Your first thing, if I wanted to multiply, say, x to the fifth times x to the third. Well, if I used this definition above, x to the fifth is x times x times x, 5 factors of x. And x to the third is x times x times x, which is 3 factors of x. In total, so if we have 5 here and 3 here, and they're all being multiplied, we can simplify this as a total of 5 plus 3, 8 factors of x. So that's equal to x to the 8th. So then again, if we see this process where we're multiplying with the same base, a shortcut instead of going through this process here is you're just going to add the exponents. So we make that our first property. So multiplying with like bases. Oops. This is called the product rule for exponents. So if you have any number to the m times any number to the n, if those bases are the same, then we just add the exponents. Okay, so when bases are the same, leave the base alone and add the exponents. Okay, the next thing then, what if we were to divide? So if I wanted to do, let's again look at something like x to the 8th divided by x to the 3rd. And on top, you're going to have 8 factors of x. Three on the bottom. So we know from simplifying fractions, we know that if it's all factored out, we can cancel one factor on top for one factor on bottom. And since they're all factors, they're all x's, so I can cancel, if I have 3 on the bottom and 8 on top, I can cancel 3 of them, 1 on top for 1 on bottom. So I cancel 3, and then, so if I had 8 total on top and I canceled 3 of them, 8 minus 3 would leave me 5. So again, a shortcut, instead of writing it all out this way, is I would just subtract the exponents. So we can skip the step in the middle and write that as a rule. So dividing with like bases. This is the quotient rule. So if you take any number to a power and divide it by the same base, you leave the base alone and you subtract the exponents. Okay. And we'll go through all the rules and then we'll do a bunch of examples. Okay, so the next rule will be zero exponent. So zero exponent for any number any non-zero real number So again, any number to the 0 power is defined to be 1. Okay, not 0, just 1. So it doesn't matter what A is. It can be anything you want it to be. You raise the 0 power, you get 1. Where this comes from actually is a consequence of, you have to define it this way, as a consequence of the quotient rule we just went through. So we know that, let me give you an example with numbers. What's 8 divided by 8? Well, 8 divided by 8 is 1. But we also know that 8 divided by 8 is, so let me write it this way. 8 divided by 8 is, or 8 is 2 times 2 times 2. And we can write as exponents. And since the bases are the same from the rule we just went over, the quotient rule, if you leave the base alone and you subtract the exponents, well, 3 minus 3 is 0. So 2 to the 0 has to be 1 for this chain of events to be all equal. Okay, otherwise we'd get a contradiction. So any number to the 0 has to be 1, and you can go through this. We could change these to A's and get the same thing. So anyway, that's 0 exponent. Next rule is negative exponents. A to the negative n is defined to be 1 over A to the n. And again, this is a consequence of the quotient rule too. If we look at it, think of it this way. If we go back to, say, x to the third over x to the fifth, and you have 3 x's on top, 5 on bottom, you cancel 1 for 1. We always know there's always a 1 there if everything cancels. So we get 1 over x squared. But if we use the quotient rule, x to the third over x to the fifth is supposed to be you subtract the exponents. 3 minus 5 would be negative 2. So again, if you just follow the chain of events here, this chain of equals, x to the negative 2 would have to be defined to be 1 over x to 2. Otherwise, you get a contradiction. So that's how negative exponents are. Anything to the negative exponent, it makes it the reciprocal, and you just change the sign. So, well, I'll talk about that in a second. I actually have a couple of alternate ways that I think about exponents, negative exponents. Oh, and actually okay, so the next one is the power rule. Okay, so the power rule. So if we take any number, raise it to a power, and then you take that expression and raise it to a power, what you're going to get is a to the m n. And what you do, so power to a power, you multiply the powers. Let me just do an example of that one, show you where it comes from. So if I had like x to the third to the fourth, what this means, this 4 here says you're going to multiply this x to the third 4 times. We're going to have 4 factors of x to the third. And then using the addition rule, if we're multiplying the same base stays the same, we're going to add the exponents. Well, a shortcut of doing 3 plus 3 plus 3 plus 3, you could say 3 times 4, right? 3 4 times. So 3 times 4 is 12. So what we can do is cut to the chase, skip all this work in the middle, go from here to here. If you take a power to a power, you just multiply the exponents. So 3 times 4 is 12. Okay. Then we're going to do raising a product to a power. So a product is the result of multiplying 2 numbers, 2 or more numbers. So here's a product of 2 numbers. And if I raise that to a power, the result's going to be, I'm going to take each factor in the product and raise it to that power. So if I had x, y to the third, again, if I go by the definition of exponent, I'm going to have xy times xy times xy. This is all multiplying, so I can drop the parentheses, I can rearrange the order, move all my x's to the front, all the y's to the back, and since you got 3 x's multiplied together, that's x to the third, 3 y's, y to the third. So again, we create this rule so we can just cut to the chase. It's a shortcut. Instead of showing all this work, you're just going to say the result's going to be, if you have a product raised to a power, you're just going to raise each factor in the product to that power. So a lot of people say, oh, it's a distributive property, right? Well, it has that feel, but it's, you know, it's this rule. It's raising a product to a power. So it's not distributive, even though it kind of feels that way, right? So it's x to the third, y to the third. So you're going to raise each thing in the product to that power. All right. And then the last one we'll cover, and then we'll do a whole bunch of examples. One class I would do a whole bunch. We'll see how many we do here. So raising a quotient to a power. So a quotient is the result of dividing 2 numbers. If we raise that to a power, the result's going to be, we're going to raise each number in the quotient to that power. Again, an example would be if I had x over y to the third. By definition of exponent, it's going to be x over y times x over y times x over y. So you got 3 factors of x over y. And again, it's right here, this is all multiplying, so I can drop those parentheses. And how do you multiply fractions? Right, so we're going to multiply all the numerators, we're going to multiply all the denominators, and then since the numerator is x times x times x, you got x to the third power over y to the third power. So again, this rule, this property here is created so you can cut to the chase. So again, it's going to, if you take a product to a power, the net results, you're just going to raise each one of these things. Oh, I'm sorry, a quotient to a power. You're going to raise each number in the quotient to that power. Okay, so that's a nice little shortcut. So if I had x to the fifth, xy to the fifth, that's just going to be x to the fifth, y to the fifth. And you just cut to the chase. All right. So let's summarize all the properties. So we should have it just in one page so you can refer to it. Now, it's important that you're going to, you should know these inside and out. So we're just going to rewrite them all in one place. So I don't think I talked about this one. So what does it mean? What's any number to the first power? Well, that's defined to be just itself. We got any number to 0 is 1. We have negative exponents. 1 over a to the n. Alternate way you can think of negative exponents. If you have a fraction to negative exponent, the negative flips the fraction over. And then that changes the sign to positive. And then, of course, you can apply the quotient rule. So then you're going to get b to the n over a to the n. And another alternate would be I'll talk about it later. We'll write it down in an example. Okay, the next thing, product rule. If you have this multiply with the same bases, you add the exponents. Quotient rule. If you divide with the same bases, subtract the exponents. Power rule. If you take a number, raise it to a power, and raise that to another power, you just multiply the exponents. So power to power, you multiply the exponents. Then taking a product to a power, I'm going to raise each number in the product to that power. And finally, if you have a quotient to a power, you're going to raise each number in that quotient to a power. All right, so keep that handy, and we're going to refer to it as we do a few examples. So let's look into exercises. So let me start off with a little more challenging ones. All right, so number 22. Oh, let me backtrack. Let me do number 16 first. So I got 3a to the 5th times 2a to the 4th. So again, since this is all multiplying, we can rearrange the order. Now, you don't ever write this, but I'm going to switch these two. And so I'm going to multiply the numbers, the coefficients. 3 times 2 is 6. And then I'm going to use exponent rules for this portion. So if you multiply with the same base, you add the exponents. 4 plus 5 is 9. So you get 6a to the 9th. So number 20, x to the 6th, y to the 3rd, x, y to the 4th, z to the 0. So again, it's all multiplying, so I don't have to worry about the parentheses. I can drop them. I can rearrange the order. So again, I wouldn't write this, but in my head I would think as follows. So I'm going to put all the x's together, all the y's together, and the z's together. This is 6 plus 1 would be, so normally I don't show this. You can if you want, but normally I don't. Okay, so this is x to the 7th, because multiplying bases, remember there's a 1 there. 3 plus 3, oh, I messed up, it's 3 and 4, sorry. So 3 plus 4 is 7. And then z to the 0 is just 1, so times 1, but I don't need to write it. So that would be my final answer. All right, let's go to number 28. That looks interesting. 35x to the 7th, y to the 8th, over 7xy squared. So the way I think of this is I kind of break it up into 3 distinct problems. So I'm going to do the numbers, 35 divided by 7. I'm going to do the x's. And I'm going to do the y's. And again, I wouldn't show this step, but that's kind of the thought process. So I'm going to do 35 divided by 7 is 5. Using the quotient rule, 7 minus 1, remember there's a 1 there, that's 6. And 8 minus 2 is also 6. So there's my final answer. Oh, this is a good one. Evaluate each for x equals -2. So we're going to plug in -2 in for x. So this is for -2 to the 0. Well, what's anything to the 0? Right, 1. So 4 times 1 is 4. That's it. How about 33? 4x to the 0. Now, typically, right, you would simplify inside the parentheses. So 4 times -2 is -8, and then -8 to the 0 is 1. But you don't really have to do this because we know anything to the 0 power, it doesn't matter what that is. Anything to the 0 power is 1. So you can just, I can go from here to here without substituting in, because I know that it doesn't matter what x is. Anything to the 0 power is 1. All right, let's try a few more. Write an equivalent expression without negative exponents. Now, typically, what it means to be simplified is you don't want negative exponents. So anytime you have negative exponents, okay, so typically you want to have your expressions without negative exponents. That's one of the things to simplify. So let's start with number 36. M to the -2. Well, that's just 1 over m squared, straight from the definition. 38, 5 to the -3. Okay. So the negative exponent is reciprocal, doesn't change the sign. And then 5 times 5 times 5, that one we can simplify. It's 125. Now this one, again, the negative exponent, all it does is takes this. So here's the alternate way I was talking about, is I think of negative exponent, it moves things to the other side of the fraction bar. So this, I can take this, it's on top, and I can move it to the bottom, and it becomes a positive 4. Okay, and then negative 2 in parentheses raised to the 4th power, so it's negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Now if I had the negative 2 to the negative 4 without the parentheses, so the way you should read this is the opposite of 2 to the negative 4. So this is actually negative 1 times 2 to the negative 4. So the 2, just the 2 goes to the bottom. So this answer will be negative 1/16, which is different than that one. This is negative 2 to the negative 4. This is the opposite of 2 to the negative 4. So be careful with that. So here's number 50, 5a to the negative 7, b to the 4th. And so the only thing I have to do here is I want to get rid of this negative exponent. So again, that alternate way of thinking is, if you could take any factor and move it across the fraction bar, and it changes the sign of the exponent. So I can take this, just the a to the negative 7, move it to the bottom, and it becomes positive 7. And that's it. You're done. So with that alternate way of thinking about it, if you want to move a factor across the fraction bar, it changes the sign of the exponent. And my goal is usually to not have any negative exponents. So again, I'm going to take all the negative ones and move them across the fraction bar. So this one is going to go down. That one's going to go up. That one will go down. So I'm going to have 5, the b that's up here. I'm moving the d up. Change the sign. And on bottom, I'm moving the a down, the c down, and the f squared stays there because it's already positive. And that would be my final answer. Now, this isn't simplifying, but you could go the other direction and write expressions with negative exponents. And so just remember, if you want to change sign the exponent, you just move it across the fraction bar. So if it's positive on the bottom, it's negative on top. So you can go either direction. This is considered simplified form, but there's cases where sometimes you want to write things with negative exponents. So that's the way you would do it. Excuse me. All right, so let's try a couple more. So if I had something like 92, negative 24, x to the 6, y to the 7, over 18, x cubed, y to the 9th. Now, here's the way I think of it, right? So when you're dividing, you're going to subtract the exponents. But what I do is instead of going 7 minus 9 is negative 2 on top, what I do is I'm going to take this one and move it down here and go 9 minus 7. So first let's reduce the fraction. What divides in both of these? So if I think of 24 as, let's see, 6 times 4 and 6 times 3. I can cancel the 6's, so I'm going to divide a 6 out of both of those. So that was scratch work. So I got negative 4 on top over 3. So that's the numbers. Now I'm going to use my exponent rule. 6 minus 3 is 3. And then here, instead of going 7 minus 9 is negative 2, and then I would create another step, what I'm going to do is I'm going to subtract 9 minus 7 on the bottom. So again, I wouldn't show the step. I just go right to the answer. So it'll be x to the third on top. And then 9 minus 7 is 2. So wherever the bigger number is, that's where it's going to be left. So again, if we think about it like canceling, right, we're canceling 7 of them, and there are going to be 2 left on the bottom. So 9 minus 7 is 2 on the bottom. So that's kind of the way I do it. Okay, so this one, the way I would approach it, there's a lot of different ways you can do this. Usually, if I can simplify inside here first, I'm going to do that. So let's see, the fraction can't do anything with that. Doesn't reduce the numbers. Okay, so I'm going to take this negative 1. Remember, I'm moving it up to there. So it's 4 plus 1, because it's 4 minus a minus 1. So that's 5. This one I'm going to move to the bottom. So I'm going to add y to the 4th and y squared on the bottom. So that's y to the 6th. So this simplified. Now the negative, so now here I do it in 2 stages. So the negative flips the fraction over. And then now I'm going to raise each thing to the 4th power. So that'll be 5 to the 4th, which is 625, I believe. And then 6 to the 4th, so power to power, 24. You multiply. 4 to the 4th, and power to power, multiply. So again, if it's a number to a power, you got to go 4 times 4 times 4 times 4, which is 256. 5 times 5 is 25, 125, 625. And that's your final answer. Okay, so now go to my math lab and try to complete all the exercises there.